Hello. Hear me okay? I don't know how that works. Like, do I get introduced or just start? Let's wait for one more minute. Oh, should I start? Okay. Cool. Good morning. Thank you for coming to my talk. After actually Dustin's presentation, it will be quite easy because I will probably build up in my presentation a lot of things that he mentioned. So my name is Ignat. I work for Cloudflare. I do Linux things at Cloudflare. Who here doesn't know Cloudflare? Okay, you don't? Huh?
Doesn't know what?
Doesn't know Cloudflare, what Cloudflare does. No, so we're a huge cybersecurity company and we run the internet. So sometimes when you can't access a website, it's because of us. Yeah, but basically if you have any web property, a website or application, or you want to have one in a secure and fast and reliable manner, you can use Cloudflare. Also, we provide security services for enterprises and plus a developer platform, so we kind of compete with Amazon on AWS Lambda, so we have our workers platform. You can actually develop code and run it globally. I did it personally for my personal project. I do like when you deploy code on Cloudflare, it has only one region called Earth, so you just you don't have to think about it, you just put it and it runs. But yeah, specifically for myself, I do Linux at Cloudflare, so Cloudflare has a huge distributed network around the world, mostly on-prem, a lot of data centers, many servers. Everything runs Linux, so I'm part of the Linux team. I'm passionate about system security and performance. I enjoy low-level programming like Linux Kernel, device drivers, bootloaders, and other stuff written in unsafe programming languages. I have been recently volunteered to take over the maintainership of asymmetric keys in the Linux kernel. I was passionate about the technology, but nobody else wanted to develop it, so they said, hey, if you want it, you take it. So yeah, that's kind of where I am. I also have two colleagues here from my team, and the organizers treacherously scheduled my other colleagues' talk during this time in another room, so yeah, but we also have a talk at 2 p.m. about what Dustin just told about how we did part of the things that he mentioned, verified packaging, signing packages for production at scale. So if you're interested in that type of aspect, please come be here at 2 p.m. Okay, but again, I'm actually building out on the Dustin's presentation. So again, show of hands, what do you do in this case? So you're working as normal and you have this recognizable thing. Updated software is available, like have install now, remind me later, like who would push install now? Okay, you always hand during Dustin's talk, you should like be yeah. Who will push remind me later? Some people. Now, the people who said, I will push install now, what if it's not your laptop, it's a production server? Who will push install now? Oh, Stanley. Because you know the secret, right? So yeah, when it comes to updating production systems, you have like two choices, either remind me later or just disable updates, right? Yeah. And it's kind of understandable if you run some production, right, which is impacting. Because like, how do we perceive software updates? Well, the reason is like not good, right? So we see them as monsters, like they're we have everything working, why should I touch something, right? So they can creep and introduce instability into our systems. The problem is like, but there are different types of software you can update. So you can update regular software, yeah, they're annoying, yeah, but like, what about the Linux kernel updates, right? So Linux kernel updates is this kind of a monster, right? And it's understandable because we kind of know how to deal with regular software updates if they go wrong. So like imagine you update a service, it crashes once in a while, once in a week. Well, yeah, what do we do with it? Like, we fix it? Well, no, we just like ask systemd to restart it, right? But I mean, it's okay, right? So like, yeah, we'll be in this degraded state and it will restart once in a while. Like one of a million requests will receive a 500. So yeah, we can live with that. So we're kind of done. Mostly, and we have time to fix it. When the Linux kernel crashes, it's actually a different story. There is no systemd to save you, right? Because your machine is down, right? There is nothing to restart it, and even if there is external automation that can restart your servers, it can still like take time, and your customers will notice. However, we still need to do it, right? We still need to take the risk, and Dustin slightly covered it. I'll cover it in more detail. So like, what are the common risks of not applying software updates, and specifically the Linux kernel in particular? Well, bugs, right? So if you don't, like, software updates do not happen just because developers want them to happen. It's just because they want to fix bugs. And particularly for the Linux kernel, this is statistics of number of bug fixes in every release of the Linux 6.12 kernel, like the latest LTS Linux kernel release. And these patch releases happen roughly every week, and these are a number of commits, which mean number of potential bug fixes in every release, right? So far, well, recently there was .50 release, but like I have statistics of .49. So far, out of 49, the releases that I checked, we have 38 releases, like more than 80% of bug fixes with more than 100 commits. So obviously, potentially more than 100 bug fixes. We have 19 with more than 200, so it's like 25-ish%, and we have 4 these mega releases with more than 500 commits. So imagine you're not applying a single update, and you kind of have 500 bugs lurking in your system just to be used. Well, secondly, why you should update is also for potential performance improvements. We have had many stories in Cloudflare around this, but one of these I wanted to highlight. So we were evaluating migrating a major kernel version from 5.4 to 5.10 at some point, and basically we had two servers, 2 sets of servers. They were running the old version, and like half of them were rebooted to the new version, and you can see, and this is like a memory consumption on a server, right? So like 5.10 brought us like roughly 4.5 gigabyte of memory savings per server. And RAM is expensive these days, so imagine like we can now have load our servers that will use RAM for 5 gig more. It's a big capacity boost. And this was like, and we had nothing to do with it, right? So we just took the update. It was because this is like a power of open source, like nice people from Facebook improve like memory management and the Linux kernel, and we just got it for free, right? So. Another way how to look at the bug commit statistics in the Linux kernel, and it's what kind of Dustin also touched on, is change delta. So if we reduce the graph, that every line here will be the I call them cumulative commits, so like total number of commits since the 0 release, so like .0, .1 has 1, .2 has 1 plus 2. So now we can build this kind of graph, and we can measure change delta, right? So like imagine, for example, you are running 6.12.6 kernel, and you are thinking to updating to 6.12 kernel, right? So, and the change delta between the two is 778 commits. Now, if we make a reasonable assumption that basically the number of commits, the number of changes, is somehow proportional to the risks of bugs and security vulnerabilities you are mitigating, so this is kind of like what you want to mitigate, like 7.778, right? Now let's imagine again what Dustin mentioned. You're in this enterprise which has a big Friday upcoming, and for some reason you decide to delay the update. So, and you delay it like 2x, right? So instead of going from 6.6 to 12, we go from 0.6 to 18, like we get a 2x delay, right? But now in this particular case, the change delta is 2,306. And again, these releases happen roughly a week, so we just delayed the update by 6 weeks. So we had like 6 weeks of updates, and we delayed the update by 6 weeks more, right? So 2x. But the problem is, if you calculate the difference, like you will see that the risk may not always change proportionally, right? So in this case, for a 2x delay, you get 3 times more risk of not applying the updates, just because later there were more commits and bug fixes released in these updates. Okay? So this is where we see we don't want to accumulate too much delta, and we may think that, if we just like delay a little bit more, we get a little bit more risk. No, sometimes you can get much more risk than the actual delay of update that you're applying to. We mentioned security vulnerabilities, so apart from bug fixes, we also need security vulnerabilities getting patched. A similar graph for, I scanned the Linux CV announced mailing list, the official mailing list for where kernel CV is an announcement, and it also in every message it has when a particular CV was fixed in each stable release. So basically for the Linux 6.12 kernel, it's the latest LTS. I will touch on what LTS means later. So out of 48 releases, we had 39, again more than 80%, with more than 10 CVEs patched, right? And we have 14, which is also a non-negligible portion with more than 50 CVEs patched. So what does it mean? Again, if you don't take the regular weekly patch release, you have probably 50 CVEs lurking in your system, right? Which also brings, apart from security risks, which brings compliance risk. So if you manage a system which, for example, PCI DSS compliant, you may see that it says like that all system components are protected from known vulnerabilities by installing applicable security patches. And updates as follows, and it says literally 1 month of release, right? So like you have 30 days to patch known vulnerabilities. But what does this graph means? Then like if we have a patch release, that means that vulnerability is known. So practically what it means, as soon as the patch release was released, all the patch vulnerabilities there are known, so your counter starts from there. So like you have 30 days to apply that patch release to all of your production machines. Right, Dustin also referenced this, Equifax. You know what happened to Equifax. It wasn't the Linux kernel, okay, it was any other software, but unpatched software can lead to data breaches and other stuff. And this brings us for not so fun fact that I don't know if who's old enough to remember the old 2000 sysadmin forums where sysadmins like boasted like uptime of their service. Oh, my server uptime is 3 years or 2 years, like it's not cool anymore. If your server time is about 30 days, and because to patch the kernel you need a reboot, you're not cool, right? Like you're likely vulnerable and like people will hack you definitely. Okay, this brings us to like common anti-patterns for Linux kernel releases. This is kind of based on my personal experience. When I joined Cloudflare, I kind of tried to push that agenda. But I received with the standard enterprise approach to managing software updates, right? And I think it actually doesn't apply to Linux kernel updates. So one of the typical questions was like, okay, well, you want a kernel update, which things from the changelog are applicable to us, right? Like why justify me, why you want, what bugs you want to fix? It's like, you put in this graph, okay, if I have an update with 500 commits, good, and this happens every week, right? Good luck going through the changelog every week and identifying the bug fix which is applicable to your system. So it's so much easier just to say, from these 500 commits, there's almost likely something that is applicable to our system, so let's just take it and don't waste our time, right? Similar, there's a question like, okay, you want to patch for CVEs, okay, is this security vulnerability actually exploitable on our systems, right? And sometimes it's easy to tell, like sometimes you say like, I get the CVE, like, okay, a security vulnerability was discovered in like a Mali Linux driver, right? And I know we don't run Android on our production servers, so I say like, no, it's not applicable, we don't use that hardware. done. But sometimes it's not that easy, right? It's like you have like, oh, an out-of-bound memory access was fixed in memory management system with slab 64K, like, right? So like, technically this is the right question to ask, but we're asking it for the wrong people. So who can answer that question? Actually, that question can be answered by the attacker, because like if the attacker knows that vulnerability, they're kind of highly motivated to break into the system, and they spend exclusively like almost 24/7 to find a way how to exploit that vulnerability, right? And I've been to security conferences and like even Black Hat, DEF CON. Sometimes they're really, you know, like determined. So like sometimes you don't have a critical one vulnerability, but they're able to take like 5 or more low severity vulnerabilities and cleverly chain them together to get into your system. So basically, the attacker spends like a lot of effort to get into this, and probably the attacker can answer that question, can I use this vulnerability to exploit your system? But we don't know who the attacker is. We don't ask the attacker that question. We ask that question of a Linux engineer, security engineer, who has a different profile. They're highly motivated to go home on time, right? They need, apart from this security vulnerability, which requires a lot of low-level understanding, they need to review several patches a day in several systems, so they have like a whole, they can spend on this vulnerability at least like 5 minutes. And they also have other competing priorities. Security people need to deal with compliance, we have to deal with some others, like non-security things. So we're kind of asking this person, right? So we probably won't get a good answer here or quality answer. So it's much, much safer to just like say, probably there is something that's affecting our system, let's just patch it, right? A traditional like enterprise approach, at least, and even in finance, they say like, okay, fine, we'll have your updates, but we'll soak it in Canary for 1 month to make sure like everything is like polished and stable. Well, the problem with this approach, again, if you're spending 1 month in Canary deployment, you're delaying upgrade of your production system, and you're again starting to accumulate the change delta, and you get more risk, right? From a security perspective, you're not applying and fixing bugs in your production systems. And again, we remember that by compliance, we're required to patch everything within 30 days. So we're risking to be out of compliance as well by soaking too much. So why do people ask that? So I think like high soak times probably means we actually don't know what we're looking for. So we just hope that within 1 month, if something goes wrong, it creeps up, right? So it's basically lack of metrics or observability or understanding of our workload. Yeah, we don't understand our workload. We run a highly multi-tenant systems in Cloudflare, and there are different services. Like if I ask different teams, like what is their ideal view of the kernel, like what does their kernel performance look like? Like some teams will say, yeah, sure, it's like CPU and scheduling should be monitored, and other teams will say like disk I/O should be monitored because they run a database. Other teams will say like networking is the most important thing in Cloudflare. Why do you even ask that question, right? So like people need to understand what is their workload and what particular things from the operating system they care about. And maybe lack of sufficient pre-production kernel testing, unit testing, integration tests, especially performance tests. You can unit test and integration test everything. As soon as you put it at scale, it may start to creep, right? So ideally, we should have systems stressing our production deployments like that. Again, Dustin had the slide, Big Bang, like operating system grade Big Bang. Like kernel is just too critical. It's like the most core component of everything. Let's have more approvals. Like this is what I experienced in Cloudflare. Like we needed to have a 1 SRE approval for every software update, but like, oh no, for kernel we'll have 2. and again, that's understandable because the kernel update is perceived as this monster that can crash a system, right? But what if I told you that kernel deploys are inherently safer than any other software? So updating a kernel is the safest thing you can do to your production system. And here is why. This is literally Cloudflare network. All these dots, and there are more of them, I think the map is continuously updated, represent a data center or multiple data center in some city. So we have a lot of servers, right? So how does regular software is deployed to all of that in Cloudflare? So some engineering team wants to update a package, they update the software package, and basically they package it, we use Debian into Deb, it is published into our internal software repository. Then our config manager continuously tries to apply updates, so that update is applied. And if it was a service, for example, a trigger works and restarts the service. So we're running a new service. So in this case, for regular software, if we're updating Nginx, for example, this can happen within minutes across all over the world. So new bad or good code can propagate to production in minutes without appropriate safeguards. And unfortunately, we learned it the hard way. We had a couple of global outages, which some of you may know about or experience. We have public blog posts about it. Now we have artificial safeguards to ensure that software updates do not go to production fast, instantly, like it goes very slowly in stages. Now, with the kernel, the biggest feature of a kernel upgrade, it requires a reboot. Okay, so what we need to do is we need to drain the traffic from a particular server. We need to put it out of production. We need to reboot. We need to wait for it to be reconfigured again from scratch by a config management system, run acceptance tests that everything is working as it should before it can join production, and put it back into production. And of course, we're not crazy. We're not rebooting the whole servers at random. So we have an automation which reboots these servers one by one or in batches, depending on the size of a data center. So if a data center is small, it happens one by one. If a data center is larger, so we do it in batches, like 2 or 3 at a time. Right, but once I push a new kernel to production, that process starts, but it doesn't reboot everything at once, right? So there's an inherently slow-paced gradual rollout with minimal impact. So if we see a regression, we see it after 2 or 3 servers being rebooted out of thousands, right? So I immediately will notice and we stop the release. So there's literally a lot of room to stop the release, even like if you don't do artificial safeguards. Okay? Are you convinced now? Many times when we deal with Linux kernel releases, I notice that people don't understand the Linux kernel release strategy, right? So like I'll just spend some time on that. So Linux kernel versions are denoted by 3 numbers. Number, dot, number, dot, number, right? For example, 6.12.32. Who here is familiar with semantic versioning? Okay. So one thing to remember, this is not a semantic versioning system. Okay? It looks like semantic versioning, but it's not. Instead, the first 2 numbers designate a major number, not major minor as in semantic versioning. The rightmost number is only for bugs and security fixes. So when that increments, you will never get any new features or major subsystem rewrite. That's why it's very, you should always take these, right? So like these will never, like these really rarely have any regressions because they're only bug fixes for your system. Nobody's going to rewrite memory management here. So how kernel release flow works? So we call it the mainline branch, where the bleeding edge Linux code is stored, still managed by this guy, you know who he is. But development doesn't happen on this branch, so like there are like subsystem branches, a tree of subsystem branches. So for example, we have a subsystem for drivers, we have a tree for memory management, we have a tree for networking, etc., etc. And at some point in time, we call it a merge window. All new features developed on these branches are merged. We're actually in the merge window right now. So now this process is happening right now. So all these new features are merged into the Linus branch, and at some point, Linus branches out his branch and creates a stable release. And stable release is designated by first two numbers in the version. So we have like 6.1, 6.2, 6.3, right? And this happens every 9 to 10 weeks. Okay? And then on these stable branches, they're maintained by stable maintainers where all the bug fixes and security vulnerabilities are being ported. So at some point, and these bug fix releases are tagged from a stable branch using just tags, right? So like you have tag for 6.2.1, etc. But what happens with the bug fix? What does a bug fix process look like? So if you found a bug, you don't commit it directly to the stable branch because we want that bug to be fixed everywhere, right? So like in the bleeding edge, you're likely running the stable kernel, but we want the bug to be fixed everywhere. So if you found a bug fix and patch it, you submit a bug fix to a respective development tree. So like if your bug is in the drivers, you'll go to the drivers tree and submit your bug fix. Eventually, that bug will get propagated to the mainline branch for Linux. And then the stable maintainers who maintain the stable branch, these bug fixes are commits that are specifically tagged as a bug fix. One way or another, there are multiple ways to tag a bug fix commit. So they monitor for these commits and they literally cherry pick them from the mainline branch, right? And when there are enough bug fixes accumulated, they do another bug fix release. And these releases happen roughly every week, so with another tag. Okay? Clear? Yeah. The one thing to notice that stable branches do not linger for a long time. So stable branches are maintained for patches, for bugs and security vulnerabilities, as long as the next table is not released. As soon as the next table is released, the previous table is stopped being maintained because the expectation is that you should upgrade to the next stable version. Now, so basically a new major stable kernel version is released roughly in 9 to 10 weeks, and it requires 2 weeks for development. This is a merge window where actually, well, development happened earlier, but in the merge window, the features get merged into together, and then 7 weeks of bug fixing. So a stable version usually goes through 7 rounds of release candidate releases, and then you have a really good release. And the other thing to remember is that leftmost version means nothing. This is another thing that I had to explain to our SRE team, that they at some point were upgraded like from 5 point something to 6, and they're like, oh, this is probably even more scary update because we had the 5 kernel and now we have the 6 kernel. So again, leftmost version means nothing, so you can have more features from 4.19 to 4.20 than you would have to from 4.20 to 5.0. I think the joke is, I think what Linus said once, that like, I will upgrade the leftmost number when the version gets too big, and too big at his definition means when he runs out of fingers. But sometimes he kind of like bumps it from .21, but sometimes he bumps it from .19. So like he has like a variable number of fingers, I think. But anyway, yeah, like he just decides it arbitrarily. So yeah, the leftmost version means nothing. So you shouldn't do more rigorous testing when we will upgrade for 6 point something to 7.0 kernel. So like it will be, and will happen soon, I guess, sometime next year. Yeah, and bug fix patch releases are released around once a week, denoted by the rightmost version number, usually cherry-picked from the main Linux branch. There's never new features, therefore regressions are quite rare. So like, we had years without regressions in bug fix releases. I think recently we discovered one, but yeah. But they may contain critical security patches, and you always want to apply them. So these bug fix releases should be applied to a system with no question asked, no drama, no process. Now let's talk about LTS releases. So usually a stable release branch is active around 2 to 3 months. After that, it's end of life. So like stable maintainers drop support for it, and they don't backport bugs and security features anymore, with the expectation that a new major stable version should be available at this point. The problem is in production systems, this is where you get new features and major subsystem rewrites, so you have to reevaluate, right, if it breaks anything. But it's probably hard in an enterprise environment to do it every 2 to 3 months. So there are also long-term stable releases where bugs and security fixes are backported for at least 2 years, and usually it's the last stable release of the year. So this is why I showed 6.12. 6.12 was the last stable release of the last year, so it's the latest LTS branch, and this year I think 6.18 will be the LTS according to the crystal ball thing that predicts kernel releases. So yeah, so therefore a new LTS is released once a year. So it's basically, you shouldn't wait for 2 years before you evaluate the next one. You should probably evaluate the new LTS the next year, but you have like enough time for more rigid evaluations for the next long-term release. So you can literally follow the LTS releases. And that process is really well described on the kernel.org website. Okay? And understanding upstream long-term release is crucial for probably selecting the kernel on your laptop Linux distribution. So for example, LTS upstream releases do not always map to LTS releases for distributions kernel. So for example, Ubuntu does not always follow that. And recently it was funny that we found a bug in production on our 6.12 kernel. We actually diagnosed it, submitted a bug fix, got it fixed. The bug was officially backported to all stable branches, and 2 months later, the same bug, like users of Ubuntu in our company complained about the same bug. And it's like, why it's not backported? It was backported to all the stable branches. Like, yeah, we use LTS, Ubuntu 24.04, but Ubuntu LTS has 6.8 kernel as their LTS, which is not. So you're kind of like, if you're selecting a distribution kernel, which calls it LTS, you're at the mercy of the LTS team of that distribution versus you're benefiting from the whole community LTS support. So it's better, I think, like I think even you, I'm not really familiar with that, but I think in Ubuntu you can select different kernel channels, so it's better to select your kernel which matches to the upstream LTS versions if you want better support. Okay, so that brings us to safe and easy production kernel upgrades. So definitely don't create a dedicated deploy process for the Linux kernel. Kernel upgrades are usually less risky than any other software. Who disagrees? Yeah. A simple stage rollout is usually enough. And kernel upgrades are naturally slow-paced because they require a reboot. And that leaves you with a lot of headroom to abort the deploy if things look wrong. Avoid justifying bug fix kernel upgrades. So again, we see there are a lot of bug fixes going into each weekly release. There may be a lot of CVEs. Just take them, right? They should be released with no question asked. They contain only bug fixes and security patches, and because of the sheer amount of them, there are almost likely some that are always applicable to your system. Regressions are quite rare, and you should also minimize canary sock times to spearhead your update to production. Instead, try to come up with better metric-driven approach. Like if you have a database workload, watch the database, like main metrics, how many queries it can process per second. Same goes for any web server. If you have something else, watch that something else. So if you run a particular workload, you'll likely have the, like what they call an SLO, or like the main metrics that identify the health of your service. Use that as an indicator if the kernel is successful. If it looks right, continue the deployment. If it's too costly to validate a major version of the kernel with features and potential more regressions, you stay on the long-term branch, right? So you have at least 2 years of bug fixes and security patches provided by the community, but definitely don't wait for 2 years. Start evaluating the next long-term in 1 year when the next LTS is available. So this is what we do with Cloudflare. We stay on the long-term branch, but as soon as the new LTS is being released, we start evaluating it, and like usually this process takes a couple of months for us to be super sure that we have enough legroom. Like if something goes wrong, we still have more time and support from security patches. And yeah, but it will also allow you to, if you change major versions, more often it will allow you to accumulate less change delta, and we all agree now at this point that change delta is not great. Try to implement or improve if you don't have any pre-production testing for major version validation. Of course, like it's very hard, and we're not in the perfect spot as well at this point. So we have so many workloads. So some workloads are being tested like we'll put it on a couple of servers in production and see what happens. Of course, the ideal space would be trying to better understand your workload, and this is where you need support from that respective engineering teams. I cannot understand how all the databases that we use work. We have like ClickHouse, Postgres, custom-made, some key value stores. We have like handwritten, we have Nginx, we have handwritten replacement of Nginx, which were in Rust that were recently blogged about. So like all these workloads are different. So it's very hard to understand each workload, so you will probably need to talk to your engineering team. It's like, tell me what's important, what can I monitor when I do a kernel deploy to your system, so I'm sure it looks well. And it also helps them, because if they don't have it, they start thinking about it. Okay, like, I should probably start monitoring some things. Yeah, so make metric-driven decision, not time-based decision. Minimize SOC times. And also, like metric and monitoring and deploy automation can help with human risk perception. Again, one of the early problems in Cloudflare that we had is when I wanted to do kernel upgrades, the process was manual. So I still needed to go through our SRE team. And no matter how many times you do this presentation, in 2 weeks you hire a new member, and and their task was doing kernel upgrade, and it's like, oh, kernel upgrade, no, like I'm not touching this, I'll break everything. So the best way to remove that obstacle is automated. Now kernel upgrades are automated. I don't need to talk to SRE anymore. I just drop a new kernel version into our release system and magic happens. So sometimes they don't notice, right? Like a kernel upgrade happened in production, right? So like there's literally, you don't have to do anything. And yeah, having this automation actually encourages regular updates, because you remove the human risk perception, and like people are just happy that a system is doing something, and they just want to be paged or notified if something goes wrong. But if everything is quiet, people are just happy. Okay, so some conclusions. Again, kernel upgrades are less risky than any other software. Patch early and patch often. Take this minimal delta approach. Bug fix kernel releases should be applied with no question asked, and do apply them on your own laptops as well. Try to understand your workload, metrics, and monitoring. And automation having all this is definitely will help you stay patched and secure. I think the superpower now that we have Cloudflare, which I speak to many other companies and they don't have, is reboot automation. Like if you can reboot any server safely anytime, it gets you like 90% of the way for most things. Like, and it's not only kernel upgrades, like firmware upgrades, drivers, hardware maintenance, everything. Like reboot automation is literally a superpower. Thank you very much, and I'm happy to answer some questions. Any questions? You can shout, or I can repeat, or I can give them, hello, is this working? No, it should work. Thank you.
Hello, thank you for the talk. One thing I want to mention is that the stable maintainers have started to use an AI agentic flow for identifying patches to backport. And so there's inherently going to be a little bit more risk now. They document what the agents decide for the reasons to backport, but you're going to see things that were not deemed a bug fix initially that get backported, and maybe they can cause a regression now. At least within AMD GPU, which I mean, doesn't matter for servers, but for AMD GPU on laptops, there's been a number of patches that got backported from the agentic workflows that caused breakage across the board.
And I'm actually, this a nice comment because I'm not aware of that and I didn't research it. Like you say, like upstream Linux kernel maintainers now use agentic workflows?
Specifically stable maintainers.
Maintainers.
Sat Oct has a cloud-based script that he uses for this purpose.
Okay, yeah, I have to research of that. So maybe, yeah, but I guess with any system there is a perception or there is actual data. It would be nice to measure it, right? So like we kind of try to understand as I said, the perception of like, yeah, we keep upgrading these kernels automatically, like what went wrong in the past year, and there are years where nothing gets wrong, there are years when one thing goes wrong. Like if we start seeing two or three things going wrong, then probably, yeah, we should like reevaluate this approach, of course.
Another thing that'd be worth considering is using agentic workflow to make your decision to upgrade the kernel. If you want to scan the changelog, AI agents can do a lot better than humans can.
Well, yes, I agree. But I don't know. So far, my experience with AI and kernel development was not great because I asked it to write me a self-contained RSA implementation in C. I asked actually 3 different providers, and they all tried to trick me. The Gemini one even like insisted that I was wrong in like a Google persistent way, even though they wrote me crap. So like, I don't know if AI is trained well enough, at least for now, to understand like, again, the same type of security patch that like I would debug. It's like, oh yes, there is an out-of-bound memory access and slab memory manager. Like, how is it widespread? What kind of workload will trigger it? So, like, I would love to see these tools, but I would rather, again, that's why I say reboot is a superpower. Reboot is a simple system combined with metrics. I would rather not make any decision. I would just apply updates. And if nothing breaks, I'm happy with them. Like, I don't want to justify all these bug fixes.
Thank you.
Anyone else? Yep. Maybe you should come forward. You just time.
So just curious, I liked the data that you presented in the beginning, like with all the CVEs and just like the patches and all that stuff. Is there something like that like gets populated for each kernel, like release and patch? Like, because I just love that data just to kind of know, kind of like, because you saw certain ones were like huge, and then there were some that were like maybe 100.
Yes, so basically previously there was a nice GitHub project called Linux Kernel CVEs that did it. I think it got kind of suspended now because like Linux kernel itself is what is the CVE authority, so they actually stamp the CVEs themselves, and the CVE announced mailing list is that official source. I don't know if there is like good like visual representation. So this graph was generated me writing a Python script which scanned everything and produced the data. I'm sure that can be developed even on Cloudflare. It should be very easy.
It was just neat. So I just liked it.
Yeah. This is a nice idea. So maybe eventually, if I remaster web programming, I will do it. Any other questions? Okay, get out.